right, it's officially 2:30, so I'll get started. Welcome everyone who's come in. I'm going to introduce our speaker. We have Lindsey Van Wagenen, who's going to talk about sustainability modeling. I'll pass it over to you now. You have 25 minutes. I'll let you know at the 23-minute mark.
Okay, perfect. Thank you. All right. Well, I'm Lindsey Van Wagenen, and I teach at NYU's Engineering School in Brooklyn, in downtown Brooklyn. And so really a lot of what we're doing is really based on the fact that we're at an engineering school, even though in the larger context, I'm part of the Courant Institute, which services more than just the engineering school. And so let's see, all right. So in this kind of the organization of the presentation is, I thought I'd talk a little bit about the sustainability initiative, and then talk about how we're addressing it in the classes that I teach. We're modeling sustainability with ODEs. And then at the end, we can just, have some time for discussion and suggestions. And so the first thing I just thought is kind of, useful to bring into mind is the fact that we're working with kind of a UN definition of sustainability, which is meeting the needs of the present without compromising the ability of future generations to meet their own needs. So it's kind of a very nice, broad umbrella under which we're working. And so the first part is NYU's Sustainability Initiative. And kind of the two-paragraph summary of what we're doing is, surprisingly, there is no requirement for our engineering students to have any education whatsoever in sustainability or climate change. And most of them do not have any kind of formal background, even though they will be designing, the products and the systems of the future. And so the Tandon dean decided that she wanted to help change this by having a sustainability initiative that would study this. Now, NYU as a whole has long been working in sustainability, but it just hasn't been a formal part of the engineering curriculum. So our goals are to design an educational framework so that our engineers will understand the meaning of sustainability, the causes and impact of climate change and environmental pollution, and how to apply the principles of sustainable engineering to their work. And the way that we're working on this is to integrate sustainable engineering concepts into discipline-specific courses, introduce sustainable engineering principles throughout our core curriculum, and connect students to career opportunities in sustainable engineering. Now, each one of these things is greatly influenced by the fact that we're in an engineering school, which has its own very stringent accreditation requirements. And more on that in just a moment. But we're currently in the sustainability initiative, we have instructors and staff coming from the math department in the Calculus 1, Calculus 2, linear algebra, and differential equation courses are all working in the sustainability initiative. We also have physics. We also have chemical engineering, which I didn't mention. We have Introduction to Engineering and Design, which is a course that most of our engineers have to take in the first year. And nicely enough, we have the Advanced College Essay, which really adds a nice balance because communication is such an important part of an engineer's job. And also, it's really a nice framework for the students to, discuss and synthesize a lot of the material that comes up in their other courses. So, so specifically, I'll be talking about my work with sustainability modeling in an ordinary differential equations class that also has linear algebra in it. So again, our specific mission is to build student engagement and skills using differential equations. And we want to demonstrate that mathematics is, crucial for engineering solutions, and to really do this in a very, very concrete way, so that the students, they can really string together these different themes into kind of a cohesive whole. And I've always liked this comment, this quote. So since Newton, humankind has come to realize that the laws of physics and nature, I added, are always expressed in the language of differential equations. So the specific course that I'm working in, and I think it's just kind of useful to kind of show you what our constraints are, because that's really motivated how we deal with many things. So this is a differential equations with linear algebra course. It's actually somewhat common at engineering schools because we have the very rigorous ABET accreditation constraints. And ABET, if you're not familiar with them, really structures very, very highly what engineering education is like. And the students have almost no electives. And as more and more technology and best practices get introduced into the engineering discipline, and we want to bring them into their education, there's fewer and fewer credits available for basic things like differential equations and linear algebra, which would both really benefit from having their own course. So we do it together. It's primarily a differential equations course with enough linear algebra. But because many of the computer science engineering students, this is their full exposure to linear algebra, we need to spend a fair amount of time on it. So this one course has to do all these things. It's a 1 semester 4-credit course for sophomore engineering students. It's the prerequisite for approximately 20 courses from financial engineering, computer engineering, civil, mechanical engineering, electrical engineering, so on and so forth. And so we cover, the standard curriculum: first order differential equations, slope fields, classic models, higher order linear ODEs. Then we do probably a 4-week module on linear algebra, where we hit many of the necessary topics for differential equations that so that they can understand eigenvalues, eigenvectors, linear transformation, change of basis. And then, because it's an engineering school, the engineering departments want the students to be able to solve systems of linear differential equations. And so we also expose them to nonlinear systems, predator-prey, and then systems of first-order linear differential equations and Laplace transforms. So we have to do all that. So as I say, too much to cover, too little time. Too much interesting things to cover. And so we're looking to create kind of case studies and modules that, in the context real world models, that we can build student engagement and skills. And we rely on the work by SIMODEs, their scenarios, their textbook. The students participate in the STUDEM challenge in the fall. We use the Slopes app a lot by Tim Lucas, and I know he's giving a presentation, maybe, I don't know if it's today or tomorrow, but if you're not familiar with that app, I found it very helpful. And then the Blanchard, Devaney, and Hall's differential equations book has proved to be like a really helpful resource for coming up with models and worksheets. So what I'll just put this slide here. I didn't know whether it should go before or after the next one, but what we do in our semester, kind of our roadmap, is we start off with the first order differential equations, slope fields, and so on, all the classic models. And then we really focus on autonomous models and the logistic equation. And so one of our sustainability projects is a very, very classic one. It's the logistic model with different modifications, fisheries, constant and proportional harvesting. And we use it to introduce bifurcation, working with parameters, the stability of solutions, and sometimes the concept of hysteresis in terms of a climate model. So there's 4 or 5 worksheets or projects each semester. And so one of them would be on the first order. Then we have a worksheet on simple harmonic motion and resonance. Then we have another worksheet on linear algebra. And then we have nonlinear models, predator-prey, and we work with systems, and we're looking at helping the students learn to interpret and modify models, changing parameters, finding equilibrium solutions. And then we have a first order linear systems worksheet where we revisit some of the earlier topics that we've talked about before. So let me just see. Okay. So what modeling sustainability in the course, in the context of math classes presents a number of challenges in the sense that we're working, like it's a math class. The students are coming from all different academic disciplines. So we can't really assume that we can, that the students have a strong physics background. We can't assume they have a strong chemistry background. We can't assume that they're really used to working and converting with units. And so, and we can't assume that our faculty, which often includes adjunct faculty, is familiar with these topics as well. So I put this in the context of that because even though we're part of the sustainability initiative and we want to, convey topics of sustainability, it's turned out to be more effective just to focus on a few topics that actually, and then make these topics that are mathematical be the focus of the worksheet, but it's done in an example that's modeling climate or sustainability. And so what that means actually is that we're focusing on teaching the students about working with parameters, interpreting solutions, and then topics like bifurcations, that small changes in initial conditions can lead to very diverse outcomes, and also that there's a lot of unintended consequences. And so that's why it's good to look at, the implications of your model. So the two examples, one I mentioned already was the pretty standard nonlinear first order, modified logistic equation in various forms. And the second kinds of systems we've been working with are first order linear systems, either the predator-prey or we have one that deals with parameter sensitivity, a pesticide problem, and unintended consequences. And then we also have a worksheet on first order linear systems dealing with carbon budget and different scenarios for carbon sequestration and reducing the amount of carbon dioxide in the atmosphere. And let's see, okay. And so I'm just putting in a little note here because I'm on my computer and my computer doesn't have a touch screen. I can't use the Slopes app to show you it. But as I said, if you are not familiar with it, it's a wonderful, powerful, fun app that the students find very, very intuitive. It does not have a lot of documentation, so you need to play around with it a little bit. But what's very, very nice about it is that you can just, it comes with preloaded models, but you can just type in the model that you want, and then you, in one version here for, let's see if this is for slope fields, you can just look at the different solutions and the equilibrium solutions, and you have your initial values here. And if you're working with systems, as I am in this over here, you'll get the phase plane, and you'll also get the solutions here, and you can turn it on to animate it to have it track. So, the students find it very fun, and it allows them to easily play with parameters. You can do the same thing with Desmos and GeoGebra, but the Slopes kind of puts it all together because you see it does most of what we need to do in first course in ODEs, and it makes it, kind of a one go-to app. Now, let's see, there's one slide. Oh, yeah. So I knew that I missed a slide along the way. And so I did, before we go into the actual worksheets, I just wanted to mention that, as I said before, the considerations that we had when we designed these worksheets is that not all of our faculty members are comfortable teaching material outside their field of expertise. We work with a number of adjuncts, and their contract is very specific. We can't really ask them to do a lot of other things. And if they're not interested in expanding their repertoire, then we really can't require it of them. And as we know, student evaluations, faculty and adjuncts maybe in particular, are very sensitive to it. And so people don't want to be placed in situations where they don't look good or they can't answer all the questions. And we need to design the worksheet so that they have a manageable learning curve for both the faculty and for the students. And so we can't really assume that they have any in-depth background. We can't favor one discipline over another. And this is a course, this is not a course on climate change or sustainability. It's really a math course. And when if we cross over that line, we get a lot of pushback, both from students and faculty. Student engagement with topics of climate change and sustainability is tricky. This is what I have found. And so it works much, much better if the topics are math topics, but they're embedded in a real world scenario that is about climate change and sustainability. And we wanted interesting, specific modeling case studies. And so again, on the right here, I think I mentioned this before, but sometimes it's easier just to see it printed. The topics we chose to embed in these case studies want to teach the students to work with parameters. That's something we find that they have difficulty doing. We want to discuss nonlinearity and parameter sensitivity, bifurcation, hysteresis, and unintended consequences. So those are what we're hoping will be the takeaways, in addition to just basic skills, skill enhancement. Okay. And so, one example that we did is a predator-prey modeling. It's a kind of a Lacta Volterra. And at first, we just present the standard predator-prey, and we ask them to investigate it using the slopes app. And what was surprising to me is, of all the worksheets I've made over the last 10 years that I've been doing on this turned out to be the one that both the instructors and students enjoyed the most. And it was incredibly simple because we just gave them some values for A, B, C, and D, and we asked them to look at what the predator-prey looked like, and then double A, double B, half A, half B, and then actually write a scenario like what that would mean in terms of a predator-prey situation. And so the students used the app in this case, and they would turn in what their graphs look like, and then they would write up a little scenario about what it was. You can have them find the equilibrium values. And as I said before, with slopes, you get not only the phase plane portrait, but you can also see what the solutions are. And that kind of drives home to the students, like what it means to be an equilibrium solution. Somehow that's not always, wasn't so clear. And then what we did is we did a modification of a problem in Blanchard, Devaney, and Hall, where we looked at a predator-prey problem in terms of pesticides. And the idea is that there was a predator-prey system in a wheat field, and then a farmer just puts a lot of pesticides on the field to kill one of the predator-prey insects. And so looking at the consequences of this. And so what's very nice about these little systems, which are actually the preloaded values in the slopes app, is that if you make the initial conditions small but not zero, you see that the populations of both the predator in green and the prey in red, and the prey is what's killed by the farmer's insecticide. And so what we had the students do is like do this and then write a letter to the editor or a blog about, what they felt were the consequences of this, because even though the farmer had like wiped out almost all of the insects, they didn't wipe them all out. And in this model, they keep coming back. And the students had a lot of fun, and their letters to the editor were actually very, very nice, worth reading. And then another part of this is we looked at the reintroduction of wolves into Yellowstone National Park, which there's some very nice videos. I know that some of it is a little bit controversial, but nonetheless, it, again, unintended consequences, this time in the positive sense, showing how things are connected and small changes in initial values lead to large changes. So this was our nonlinear worksheet. And then we have another worksheet on our carbon budget. And here we did a system, just very, very simple system about CO2 processes in the atmosphere and then fossil fuel emissions. And we just had the students work with the parameters. And so we gave them 4 different sets that come from the literature and are fairly realistic. And we just asked them to design scenarios, to just look at different scenarios and to see eventually if, the IPCC and other scientific agencies feel that we would need to get the carbon dioxide level back to 350 parts per million. Could they do that? Like, what would they have to, what kinds of parameters would they have to achieve? And then they could write about it too. So it fostered discussion. They seemed to enjoy doing it. They did a really nice, thoughtful job. And we used the slopes app again, and here's one of their more successful models. So those are just some. Right now we're working on a mixing problem with COVID in wastewater, and trying to, finish that up. So we're looking at, examples that are kind of current. And so just to summarize our results, what was really gratifying about the sustainability initiative, we've been a part of it for not very long, for about formally probably about a year now. Maybe we're in our 3rd semester of formally doing it. But what we found is it increased student engagement, which was really nice. I have to run workshops and the students come, and it's really been a nice way to work more with the students. But the thing that's been really surprising is the faculty engagement. The faculty have been really engaged, and lots of feedback. We like using the slopes app. It's really fun and easy to use. I think it deepens the students' understanding of the course material, as do these various scenarios. What these worksheets have done is it's created a framework for working with sustainability topics in the context of math courses. I must say it's taken a lot of extra support and work. I really want to do this. And so I realized like I can't ask my team, because I often have 7 different instructors. I really can't ask them to do other things that are outside their area of expertise. And so I need to have, I support this effort with extra question and answer sessions, video tutorials, and I find it's totally worth it. I'm really, really happy with how it's been evolving. The Slopes Act does not have much documentation. I've told Tim Lucas this, and so I'm, and he has more that he'll make available, but it's a really wonderful app. And I found that other faculty are beginning to incorporate these topics into their courses once they see, how it can be done. And I think the more we do it, the less work it will be for me. And so kind of to finish off, let's see, let me get this to go to the final slide. Oh, yes. So I wanted to give a big thanks. This is our sustainability team, not all of whom are math. And of course, to Brian Winkle for all of his work over the years and his, support and patience and all that. And so now I guess if we have any time for questions, suggestions, and if you're interested in collaborating and working on worksheets that have to do with climate change or sustainability, I would be very interested in working with you. And this is my email. And I hope that I can make my worksheets and all of our work available. But for the moment, I don't really feel it's ready for prime time. But maybe after the end of this semester, it will be ready for prime time. So if you can get back in touch with me, and I'll be happy to share them with you, like once all the bugs are out of them. So I think they need to go through the student filter one more time before that. So that's it. Thank you for listening. And if you have any questions or comments.
Thank you so much. Yeah, right before we get into questions, I do want to say that the session is technically over, but we can keep this room open as long as you'd like. Lindsey, you're in charge of this room, so if you keep this room open, you can keep answering questions. But if anyone else would like to move on to another session, those will start in about 5 minutes. But yes, thank you so much for this presentation. This is amazing. And now, if anyone has any questions, now's the time.
Okay, thank you.
I have an observation.
Yes, okay.
So this is a great way to keep the politics out of some of these contests.
Okay, yeah, that's exactly. Thank you for that observation. And that's definitely very much on our minds. It needs to be very neutral.
Yep.
And I also find that for the students as well, it like without like being gloom and doom or like rah, that we can solve all these problems, it's just to look at them kind of as an academic subject, and then they can draw their own conclusions. And
Correct.
I think that's why the writing seminar is so nice.
This is fantastic.
Yeah, we're really lucky that in the writing department, they're much more willing to like, tease out a lot of the more controversial aspects of it so that we don't have to do that.
But the numbers don't lie.
No, they don't lie. And the students are smart. Like they get it,
That's right. That's exactly right.
They get it.
That's exactly right. This is interesting.
I
Yes?
had a quick question. Yeah, I don't know. I think I came to your talk at JMM a couple weeks ago or something.
Okay, very possibly I gave the same talk in most part, yeah.
Yeah, no, I'm here again. I'm because it's just an interesting project, and I'd love to do something similar at my institution. But I'm trying to think how it would work. In your case, did you set up a different section and say when students are registering, hey, this is what you're signing up for, or okay?
No, that's very much why we did it the way we did it, because we run coordinated courses. I probably didn't say that. In the fall, we have like 300 students. And I have 7 to maybe 9 sections. And the students we have all these different, topics and ways that we have to cover things. So essentially what I've just done is try to build worksheets around, like, as I said, working with parameters, unintended consequences, bifurcations, but to give them the background, like each of the worksheets starts with an introduction. And I think because we're part of a sustainability initiative, like the people in the writing department are picking up on these things. And so the students, our idea was that we wanted that the students it would be more than just in math. And it would be more than just in writing. It would be more than just in their first year engineering courses, that we would just keep kind of weaving these things together so they could see the connections and they could see the value of it. And but I did this for many years. Probably the first 5 years I just did this on my own. And if I taught pre-calculus, I would have the Keeling curve, and I would ask them to, like linear model, exponential model. If I was doing calculus, I would have, integration problems where we had different models of sequestration and carbon emissions, and I would ask them to figure out how much carbon would go into the atmosphere. So it just like, I would do it I had the freedom to design the worksheets. But as was mentioned, I didn't want to step on anyone's toes, so to speak, in terms of the students assuming anything about their background or their interests even.
I'd also love to use slopes, but there's not a lot of documentation, as you say, and getting into it is a bit tricky in that how do I make a great activity that I know is going to work when there's not like worksheets? But when you get those worksheets posted, would love to see how you're doing it so I can get some ideas. But yeah,
You
I
know,
really,
and that is my aim, but I just like they need a little bit of like editing still. But the thing I was going to say about slopes is at the JMM I talked to Tim Lucas and I said, gee, it's such a great app. It would be nice if there was a little more documentation. And he told me he gave a talk at MIT and I found out what it was. And it's this beautiful talk and PDF and video of like 4 or 5 activities that you can use with slopes. And it's got questions and he's giving a talk this time, but I just Googled MIT Tim Lucas and he gave it on one of their online seminars. And I'm not sure. You can email me if you want and I'll try to send it to you. Okay.
Yeah.
Because it really helped me out a lot. And he gave this very nice talk at JMN about how he progressively, like his first day, he does population modeling, logistic, then modified logistic with the questions. And it's like with the California crayfish and whatever little lizard. And it's very nice and it's there in that talk. So it's like a if you're working on a differential equation. And I actually tried that in my class this time and it went very well because the students could just, most of them can get slopes on their phone, not all of them, but then they can work with each other. These are happy students up at the front end. We have a math modeling seminar that we're doing some of this in, and they were just like telling the instructor up at the front how to change the parameters on slope. And he was asking them, well, what does that mean then? And they were just like eating pizza and enjoying it because they're like, oh, well, that would mean that, the coffee's not ever going to cool down, and whatever they were doing. So it's very interactive and it's just visually pleasing and easy to use. And I think all of that just engages the students a lot.
thank you.
I'm just happy to add that if there is any interest, I designed some project that is based on microplastics in the ocean.
Ooh, nice.
Dynamical system. I will be discussing this, and it has a lot of bifurcation problems. So the equilibriums are stable. So the system is 3-dimensional, but it's not that difficult because of the stable equilibria. So I will be talking about this project, and there are lots of directions where it can be developed.
Oh, wonderful. When are you talking on this?
Sunday, depends on your time zone.
Oh, and I guess it's all recorded as well, but it's always nice if you can be live. I could be live, I don't know. Yeah, okay.
Very nice talk. Thank you so much.
Well, thank you for coming. And again, yes, I'm very interested in always expanding and collaborating if that works for anyone. So, but other than that, does anyone else have anything? Otherwise, we can go. I think it's the keynote talk happening now.
Yes.
Maybe we should go listen to that.
Okay.
What do you think? Okay, bye-bye.